All right, so here's class activity 3J, and this one was involving understanding subtraction algorithms. So if you were to add 147 and 195 using the paper and pencil method, you probably started at the ones place, wrote down a 2 from the ones place of 12, 7 plus 5, carried a 1, added 4 plus 9, which was 13, and added that carried 1 on for 14, recorded the 4, and carried the 1 to the hundreds place. 1 plus 1 plus 1, 100 equals 300, 343. If we were to do this with base 10 blocks, we would have 147 displayed and 195 displayed. We would then have to regroup 10 of our 1s together to form a 10, and 10 of our 10s together to form a 100. And that would result in 342, just the same, but displayed visually. Finally, this class activity asked you to consider expanded form. And the expanded form shows each place value broken down into the digit that's in that place value and the value of the place. So 1 100, 4 10s, and 7 1s formed 147. 1 100, 9 10s, and 5 1s forms 195. And it would take several steps of adding those together and then regrouping anytime we had 10 or larger in a particular place value. So the 1s would have to be regrouped to 10s, and the 10s would have to be regrouped to 100s. And this follows the same format that we used when we were regrouping the 10 blocks and the 1s blocks with the visual representation. So for class activity 3K, we were understanding the algorithm. And this follows a similar format where we would be subtracting 125 minus 68. We'd start at the ones place and realize that we cannot take 8 from the 5 ones that are in 125. So we would need to borrow a 10 from the 2 in 125. We'd take that, we'd turn that into a 1, and carry the 1 over to the ones place because we'd be taking a 10 out and adding those 10 now 1s to the ones place to form 15. 15 minus 8 is 7. And then we look at the tens place. Now we have 1 10, and we're trying to subtract 6 10s from it. Since we can't do that, we need to borrow again from the hundreds place. We'd take 100 and turn it into 10 10s. Those 10 10s would be added to the 1 10 that is there. 11 10s minus 6 10s is 5 10s. The answer is 57. And again, we can show that visually, where we'd have to break apart one of our 10s into 10 1s so that we were able to take from those 10 1s 8 from our subtrahend, and then we'd have to break apart the 1 100 into 10 10s and take away 6 of those 10 10s and form 57. When we got to the expanded form, we had to first rewrite the subtrahend. Is that right? Sorry, we had to rewrite the minuend, the first value in a subtraction problem, by regrouping first. So our 1 100 turns to 10 10s. We have one of the 10s being regrouped into 10 1s. So 1 100 plus 2 10s plus 5 1s can also be written as 10 10s plus 1 10 plus 15 1s. And if we combine like terms, we get 11 10s and 15 1s. From there, we could subtract the 6 10s and 8 1s in our subtrahend. And the difference would be 5 10s and 7 1s, which is also shown in the visual diagram. Now, if we were to subtract 104 minus 47, we'd be going through the same exact process that we did in the previous problem, where we would need to borrow from larger place values in order to have enough values enough digits in that place value to subtract the subtrahend.